Hi, this is Kirtana from Sri Venkateshwara College of Engineering, Bangalore. Let us discuss about the topic complex integrities in the subject complex analysis, probability and statistical methods with the subject code 21 MAT 41. Introduction to the complex integral. Complex integrals are a branch of mathematics that deals with the integration of functions involving complex numbers. They are used in various fields such as physics, engineering, and mathematics to solve problems involving complex variables. Complex integrals extend the concept of integration from real numbers to complex numbers. Definition of complex integral. A complex integral is defined as the limits of a sum of complex numbers as the partition of interval becomes finer. It represents the area under a curve in complex plane. The complex integral of a function f of z along a curve C is denoted as integration f of z into dz. Types of complex integrals. Line integrals. These integrals are taken along a curve in complex plane. Contour integrals. These integrals are evaluated around a closed curve in the complex plane. Path integrals. These integrals are calculated along a specific path in the complex plane. Cauchy's theorem. Cauchy's theorem states that if a function f of z is analytic in a simply connected region R, then the contour integral of f of z around any closed curve C within R is 0. This theorem is a fundamental result in complex analysis and has various applications in physics and engineering. It allows us to solve complex integrals by evaluating them over simpler paths or contours. Cauchy's integral formula. Cauchy's integral formula relates the values of a function inside a closed curve to its values on the curve itself. It states that if f of z is analytic within and on a simple closed curve C, then for any point A inside C, the value of f of A is given by the formula f of A is equals to 1 by 2 pi I into integral of f of z divided by z minus A into dz. This formula is a powerful tool for evaluating complex integrals and finding the values of analytic functions. Here we can see the Cauchy's integral formula, that is f of a is equals to 1 by 2 pi I integrate to C f of z divided by z minus a into dz. Residue theorem. The residue theorem relates the value of a complex integral around a closed curve to the sum of residues of a function inside the curve. It states that if f of z is a analytic within and on a closed curve C except for isolated singularities, then the value of integral is equal to 2 pi I times the sum of residues. The residue theorem simplifies the evaluation of complex integrals by focusing on the singularities of the function. Singularities in complex integrals. Singularities are points where a function is not analytic or where it is not defined. They can be classified as removable poles or essential singularities. Residues play a crucial role in evaluating complex integrals around singularities. Application of complex integrals in the physics. Quantum mechanics. Complex integrals are used to calculate expectations, values, and probabilities in quantum mechanics. Electromagnetism. Complex integration is applied to solve problems related to electric and magnetic fields. Fluid dynamics. Complex integrals help in analyzing complex flow patterns in fluid dynamics. Application of complex integrals in engineering. Signal processing. Complex integrals are used to analyze signals and systems in electrical engineering. Control systems. Complex integration techniques are applied to analyze and design control systems. Communications. Complex integrals are utilized in the analysis of transmission and coding schemes in communication systems. Limitations and challenges in complex integrals. Complex integrals can be challenging to evaluate analytically for complex functions. The presence of singularities and branch cuts can complicate the evaluation process. Numerical methods such as numerical integration techniques and computer simulations are often employed to overcome these challenges. Summary of key points. Complex integrals extend the concept of integration to complex numbers. Cauchy's theorem and Cauchy's integral formula are fundamental results in complex analysis. Residue theorem simplifies the evaluation of complex integrals around singularities. Conclusion. Complex integrals are a powerful tool in mathematics and its applications. They provide a deeper understanding of functions involving complex numbers. Complex integrals have diverse applications in physics, engineering, and other fields. Thank you.